Hello, in this design and analysis of algorithm video, we are going to discuss how to find the longest common subsequence among two strings. This video will be divided in four major points. First, we discuss about the subsequence concept. Then we look at different way to approach the problem and determine the time complexity of that approach. After that, we will see a specific method, which is the recursive solving method to solve the problem. And finally, we will learn about memorization, which will greatly help reducing the time complexity of solving the longest common subsequence problem. So what is a subsequence? A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. Now, to understand it properly, let's say we have a sequence or string A, I, B, F, C, T. Its subsequence can be AICT or BFD because they are following their order even if some characters in between are missing. They are subsequence of the string. But BAT is not a subsequence because it broke the one rule that is to always stay in order. So we see that to be a subsequence, maintaining order is essential. Now let's compare these two strings. We see there exists a longest common subsequence and the sequence is 4 length long. But if we select characters in a different way, we also get a different subsequence that is 4 length long. So which one do we select? The answer is there can be many longest subsequences that are the same length but yet completely different, and selecting any one of them is the correct approach. We have understood what a subsequence is. Now let's see some methods to solve this longest common subsequence problem and their time complexity. Here first we need to know a little bit about the time complexity. The time complexity is the computational complexity that describes the amount of computer time it takes to run an algorithm. It is a complete mathematical way to find out the general form of required time of a particular program in all type of devices. So to solve the problem, we can go for the brute force method. Here we take all the possible subsequence from A and then compare it with B to find the longest common subsequence. But this method has a major flaw, that is the time complexity. You see, if we take all the subsequence of A, which is m length long, and compare it with n length long B, then we will be comparing 2 to the power n subsequence from A with n length long B sequence, which leads us to n into 2 to the power m time complexity. It is one of the worst time complexity we can get, an exponential time complexity. So we cannot approach in that method. Well then, let's look at the recursion solving method. Here we compare all the characters one by one using the recursion method. If the character matches, then we go for the next character in A and B. If they don't match, then we take the maximum length we can get by increasing A or by increasing B. And the recursion breaking condition is if we hit the null in either A or b while comparing, then we will return 0. But this approach also has an exponential time complexity, so we cannot use it either. But the memorization method that is used in the recursion method will surely reduce the time complexity to m into n. We will see this approach in the end of the video. To get the best time complexity, we need to see the recursion method first. This is the code for recursion method. Here we start to compare both sequence A and B from the start. That means we start from their index 0. If they matches, then we go to the next index in the both A and B. If they don't match, then we call the recursion where A is increased by 1 and B is constant, and another where A is constant and B is increasing by 1. And we already discussed about the breaking condition. So let's see a simulation to understand it better. Here we are building the recursion tree as we go. We are comparing A0 and B0 index and found out that they are not equal. So we increase A and keep the B constant and call the recursion, and also we kept the A constant and increased the B, called the recursion. Like this. We are drawing every branch of recursion tree at once. So for convenience, let's just concentrate on the left branch only. As we see, the left branch where A1 and B0 are not equal, so the same else condition will apply again, resulting two different branch. Now here in the two branch, we can see that in A2 and B0 we have a null character. So this branch will end and return 0. But the other branch, A1 and B1, is not equal. So that branch will go to the else condition again. There it generates one branch that will return 0 and another that will go to the else condition. There again, in one branch we get a returned 0 for the null, but we also get a match in A1 and B3 index. So from that branch we add 1, and as the condition, the A and B will increase by 1. After increasing A and B by 1, we get null character, so we return 0. So here we have completed out recursion tree on the left and completed the whole recursion tree as well. Here in the complete recursion tree, we have maximum value of 2. So we have a common substring that is 2 length long. Now if we see the full recursion tree closely, we can see the recursion tree have calculated some branch twice. This is a problem. In dynamic programming, we memorize the previous values, and when the same call occurs, then the previous stored value will be used. This method will greatly reduce the time complexity of the program. Now let's see the memorization method in the recursion. First we set the condition for this method. If the I or the j is 0, then we return 0. If the values in the sequences matches, then we take the value that is stored in the top diagonal and add 1 to it. And if the values don't match, then we take the maximum value from the left and the top of that index. Now let's see the simulation. Let's take two sequences A and B. Here we took a matrix that has column equal to the length of B and rows equal to the length of A. Let's assume in the 0 index the length of both A and B are 0. So at 1, 0 index, A has a length of 1 and B has a length of 0. And like that, we assign A and B to the matrix. In the matrix, if the row or the column index is 0, then we assign 0 to that place, as the condition suggests. That's how we have completed the first row and the first column with 0. Now let's come to the index 1, 1. Here A has a value C and B has a value A in them. So they are not equal. As they are not equal, we need to take the maximum value from the top and left place of the matrix. Both sides has 0 in them. So let's say we took the top one and placed the value. Following this, we move on to the other places and set their values. Now, when we come to the 1, 3 index of the matrix, we get a match. So as the condition says, we need to take the top diagonal value and add 1 with it and then place that value to the 1, 3 index. And then we follow the conditions accordingly. In the last index of the matrix, we get a value of 2. Now, if we look at the method, we can see that we used the recursion method. But as the values from previous calculation remains, the time complexity is hugely reduced. Calculating the time complexity, we get m into m, which is way better than the exponential time complexity. Okay, so here we got the longest common subsequence value. Now, notice we have left an arrow in the matrix. What is that arrow for? That arrow is to determine what is the longest subsequence is. To find the longest common subsequence, we just need to follow the arrow diagonally. Tracing back, we get BD, which is our longest subsequence. Now, let's look at a bigger problem. Let's take A and B sequence. Like before, we fill up the first row and column with 0 and proceed to the rest, maintaining the conditions. Following the conditions, we get the maximum length of 3. And if we trace back diagonally, we get our longest common subsequence. So in this video, we discussed about the time complexity of brute force method and saw the procedure and time complexity of the recursion method. And we improved the time complexity of the recursion method by introducing memorization process. And this is the best time complexity we can get while solving the longest common subsequence problem. Thank you.